Hi, in this video we will introduce an inference rule called addition. Hi, this is Logic Self-Taught with Dr. Phi. In this video we will introduce a rule called addition. We will talk about how to apply it and how not to apply it. Addition, even though it looks simple, is actually quite tricky. So it's a good idea for you to watch this having rested. Addition doesn't require any special conditions for its application. We basically need to have a proposition, however complex, on its own line. It allows us to derive a disjunction with that proposition as a disjunct. Let's look at the rule in symbols. We start with any one proposition, P, and we're allowed to infer a disjunction with P as a disjunct. P can be the first disjunct or it can be the second disjunct, doesn't matter. One thing you may ask yourself is, where does the other disjunct come from? And the answer here is, it doesn't come from anywhere. R needn't even occur in the proof. And that's the very point of addition. You add anything you want. Before we look at examples that will show that addition might not appear to be very intuitive, it bears reflecting on the fact that it is truth-preserving. After all, if you've derived P in your proof already, you've established it to be true given the premises, any disjunction with P as a disjunct will be true too. Addition is truth-preserving. Not very intuitive, though, in certain applications. Consider the following examples. A teacher says, Jane got an A in logic. Addition allows us to infer Jane got an A or a B in logic. But why would we do that? We might as well infer that Jane got an A in logic or Nikki Haley won the 2020 US presidential election. But why would we make such an inference? And we can go on. We can add even more complex propositions. Jane got an A in logic, or it's not cloudy if and only if it doesn't snow, rain, or hail. All right, but what's the point? It turns out that addition can be very useful. Consider the following example. If Jane gets an A or a B in logic, she will get a new car. Jane got an A in logic. Clearly, we can infer Jane will get a new car. Moreover, it sort of looks like a straightforward application of Modus Ponens. But if you look carefully at the symbolization of this argument, you will see that the conditional in line 1 has a disjunction in the antecedent. And what we have in line 2 is a proposition that doesn't match the antecedent. So we cannot apply Modus Ponens. To apply Modus Ponens, we would need the disjunction, A or B. And it is here that addition is useful. We know that A is true, so we know that A or anything we want, here we want B, is true too. This is a perfect example where addition is called for. We need to add B to the proposition in line 2 to A, and now we can match the antecedent of the conditional in line 1 and infer the consequent by Modus Ponens. This is a kind of example of a class of examples where addition is actually very useful and we couldn't do without it. I've said already that addition doesn't require much at the outset. We just have to have a proposition. Right? It doesn't tell us what the logical structure of the proposition must be. What the rule tells us is that the result of applying addition will be a disjunction with that whole proposition as a disjunct. The problem with addition is that you have to have a kind of strategy in your head. You need to know why you want to apply addition and exactly what you will be adding. After all, you could add anything you want, so you could go on forever doing a proof by adding new lines to the proof that will be justified by addition, but that would be a tremendous waste of time. You need to know what you're adding and why you're adding that. In this case, let's add not C. Not C can be added either as a second disjunct or as the first disjunct. Here's another example. We have not A. We now decide to add a complex proposition, if B, then C, and we add it remembering to embrace the conditional in parentheses. We have to avoid any temptation to apply addition to components. This is an attempt to apply addition to the antecedent of a conditional. What you have to have as a result of applying addition is a disjunction with the original proposition as a disjunct. In this case, what we have is a conditional. But even if the result here was a disjunction, still this is a misapplication because addition was applied just to the first disjunct. In order to apply addition correctly, the whole proposition in line 1, A or B, would have to be a disjunct. So it would have to be embraced in parentheses and something would have to be added to it. What's wrong with this example? We have B given and we derive a disjunction with B as a disjunct. The problem is that B is in fact not a disjunct of the disjunction in line 2, it's a disjunct of a disjunct. The result of applying addition must be a disjunction with the proposition given as a disjunct. However, we can derive the proposition in line 2 in 2 steps. First, we will add not C to line 1 to obtain B or not C, and then we can add A to line 2 to obtain the disjunction we wanted. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.